Hi guys, so the lesson we talked about today was pretty important, so I'm going to record this so that it's here for anybody who missed today. So we've been talking about the unit circle, and we've been talking about these different angles and how each point has these XY coordinates, right? This is what we were trying to memorize for all of our quizzes. And we've also talked before about how if this is my XY coordinate, my X is cosine of this angle or this angle. These are the same, right? Just degrees and radians. Or maybe I'll use this one. My X is cosine of 30 or pi over 6. These mean the same thing. And my Y is sine of 30 or pi over 6. So this is going to be a big clue because if we notice, as our angle changes, our cosines change and our sines change, right? Our X's and Y's are different. So what we can do is we could write an equation, cosine of an angle and sine of an angle, where we are plugging in different angles and getting out our different cosine and our different sine points, and then we could graph it. And that's what we're going to do today. So I'm going to start with sine, meaning that I'm going to be looking at the y coordinates of the points at each of these angles. So when I'm going to fill out this table of values, then I'm going to graph those points here. When my angle is 0, my y is 0. So here I can say sine of 0 is 0. When my angle is 30 degrees, or pi over 6, my sine is 1/2, right? My y is 1/2. And I'm going to write that as a decimal because my y-axis scale is in decimal. So that is going to be 0.5. And I can put in parentheses 1/2 just so we know how we got that. They've already filled out that pi over 4 is square root 2 over 2, which is true. And so as a decimal, that's about 0.707. So then at pi over 3, my y is square root 3 over 2, which as a decimal is 0.866. At pi over 2, my y is 1. So pi over 2, 1. 2 pi over 3, my y is root 3 over 2, which as a decimal was 0.866. At 3 pi over 4, my y is root 2 over 2, which we know was 0.707, so 0.707. At 5 pi over 6, my y is 1/2, so as a decimal that's 0.5. And then at pi, it is 0. So I'm going to kind of just fill this out, but know that at each point, I'm looking at the y coordinates at that point. So 7 pi over 6 is going to be negative 0.5. 5 pi over 4 is going to be negative 0.707. We've already got 4 pi over 3 filled out for us. 3 pi over 2 is going to be at negative 1. 5 pi over 3 is going to be at negative 0.866. 7 pi over 4 is going to be at negative 0.707. 11 pi over 6 is going to be at negative 0.5. And 2 pi is back to 0, and so it's going to be 0. So for each of these different angles, I got out my value of sine of that angle, which is the same as the y coordinates from my unit circle. So now I can graph it. My x is going to be my angles, right? And even though they got pi's in it, we know pi is 3.14. 2 pi would be like 6.28-ish. So our scale is a little bit weird so that it's clear where our angles are at, but these are numbers, and then this is going to be the actual value of sine. So at 0, my sine was at 0, so that's going to put a point here. And I'm going to kind of just show the graph, but know that I'm getting my points from each of these. At pi over 6, I'm at 0.5. So pi over 6, 0.5. At pi over 4, I am at 0.707, so barely above 0.7. Pi over 3, I am at 8.66. Pi over 2, I am at 1. Then 2 pi over 3, I am back at 0.866. 3 pi over 4, I am at 0.707. 5 pi over 6, I am at 1/2. And pi, I am at 1. 7 pi over 6, I am at negative 0.5. Oh, just kidding, negative 0.5. 5 pi over 4, I am at negative 0.707. 4 pi over 3, I am at negative 8.66, so about halfway between 0.8 and 0.9. And 3 pi over 2, I am at negative 1. Sorry about the mess up point. Then 5 pi over 3, I am again at negative 0.866. 7 pi over 4, I am at negative 0.707. 11 pi over 6, I'm at negative 1/2. And 2 pi, I am at 0. So if I connect these, it makes a wave. And so we'll talk a lot about other things, but hopefully the reason it's a wave makes sense. We know that if we were gonna plug in negative angles, it would look pretty similar, right? It would do the same thing over here. And then if we kept going here, this would go back up because we know about coterminal angles, right? If I go 0 and go all the way around, I add 2 pi, I get back to where I started. If I add another 2 pi, I get back to where I started. If I start here and add 2 pi, I get back to where I start. So that means that, you know, no matter how big our angle is, I'm just only going to get out these same values. I would just be going around and around the circle. And when I plug in negative angles, I'm just going around the opposite direction. I could also graph this in degrees, but this time we did it in radians. So that's sine. That's what our sine graph looks like. If I flip it over, now this is a space for us to graph cosine. Remember, cosine is the x-coordinate on the unit circle. So I'm going to go back around, but this time I'm going to focus on the x-coordinates. So at 0, my x-coordinate is 1, so cosine of 0 is 1. At pi over 6, my x-coordinate is root 3 over 2, and we know from before that that's going to be 0.866. They've already got pi over 4 filled out for us. Pi over 3, my x-coordinate is 1/2, so as a decimal, that's going to be 0.5. At pi over 2, my x-coordinate is 0, so that's going to be 0. At 2 pi over 3, my x-coordinate is negative 1/2, so that's going to be negative 1/2. At 3 pi over 4, I'm at negative root 2 over 2, so that's going to be negative 0.707. At 5 pi over 6, I'm at negative root 3 over 2, so that's going to be negative 0.866. And then at pi, I am at negative 1. So I'm going to keep filling it out, and I'm just going to focus on the table, but you guys know I'm pulling these numbers from my x-coordinates of each point at the unit circle. So at 7 pi over 6, I am going to be at negative 0.866. At 5 pi over 4, I'm going to be at negative 0.707. At 4 pi over 3, I am at negative 1/2. At 3 pi over 2, I am at 0. 5 pi over 3, I am at positive 1/2. 7 pi over 4, I am at positive 0.707. At 11 pi over 6, I am at positive 0.866. And at 2 pi, I'm back to 1. So again, I got my table from the x-coordinates of all the points on the unit circle. And if I'm going to graph, at 0, I am at 1. And I'm going to focus on the graph, but I'm just pulling these points, right? Pi over 6, I'm at 0.866. So pi over 6, 0.866. At pi over 4, I am at 0.707. Pi over 3, I am at 1/2. Pi over 2, I'm at 0. 2 pi over 3, I am at negative 1/2. 3 pi over 4, I am at negative 0.707. 5 pi over 6, I am at negative 0.866. And at pi, I am at negative 1. Then 7 pi over 6, I am at negative 0.866 again. 5 pi over 4 is at negative 0.707. 5 pi over 3, 4 pi over 3, sorry, I am at negative 1/2. 3 pi over 2, I'm back to 0. 5 pi over 3, I am at positive 1/2. 7 pi over 4, I am at positive 0.707. 11 pi over 6, I'm at positive 8.66. And at 2 pi, I am back to 1. So if I'm gonna connect this, it's also a wave because, like with my coterminal angles, if I kept going, this would come back down again. That's just like a sketch. If I kept going here, this would come back down. So it is a wave. It's just that we're kind of snapshotting in the middle. And so one big key thing here, if I have my cosine graph and then I have my sine graph, one key thing to notice is that at 0, sine is at 0. At 0, cosine's at 1. So if I was just going to show you these two graphs, but I didn't tell you if it was sine or cosine, and I asked you which one is which, we should hopefully be able to see, oh, I know sine at 0, sine is at 0. So if my graph I'm showing you starts here, you could pick out that that's sine, whereas we know cosine starts at our max. So if the graph I'm showing you starts at its max, then it's going to be cosine. So anyway, we also talked about a few key feature things here. So if we start with sine, if I plug in based on my graph, I know at 0, I am at 0. At pi over 2, I am at 1. At pi, then I would be at 0 again. And so at negative pi over 2, I would be at negative 1. So if I graph that, I would just kind of look like this. And then I can also kind of keep going because I also know it's going to be continuing on forever. So then I can connect my points like this. This is the part we were looking at before, but it's still the same. I've just actually showed the negative ones this time. So where am I crossing the x-axis? I'm crossing a bunch of places, right? I'm first crossing at 0 and pi and 2 pi and negative pi. So how I'm actually going to write my x-intercepts is I'm going to say 0 plus or minus pi k. And what that k means is that I can plug in any integer, a whole number, positive whole number, and it would still be true. So I cross at 1 pi, 2 pi. We can imagine I'd cross at 3 pi, 4 pi, 5 pi, 6 pi, right? And so all this is basically saying is 0 plus or minus any number of pi's is going to be where I'm going to cross the x-axis. So don't let this confuse you. That's just a general form of saying that. Where do I cross the y-axis? At 0. So y equals 0. My domain is going to be every number. There's not really a reason I couldn't plug in a number. We're only graphing things in radians, but like I said, you could graph it in degrees if you wanted to, so we could plug in anything. But I only ever get between -1 and 1. I can't get anything bigger than 1 or anything less than -1, right? We've seen the maximum and the minimum of the graph. Remember, we've also talked about brackets versus parentheses. So we use parentheses when the numbers at the ends of our ranges of numbers, so like these or these, if they're not included, we use parentheses. If they are included, we use brackets. So we do get out a -1 and 1. This is continuous. I don't have a hole or anything. And sine is odd. If I rotate this function around the origin 180 degrees, this point would overlap this point would overlap this point, and it would re-overlap itself. So sine is odd. My local maximum is going to be 1, right? Y equals 1 when my x is equal to pi over 2 plus or minus 2 pi k. And what this is saying, because if we look here at 2 pi, my next one at 5 pi over 2 would be back at 1, right? So I have a maximum at pi over 2, and then pi over 2 plus 2 pi, right? 5 pi over 2. And so basically every coterminal angle with pi over 2 is going to be at 1. And if we go back to our unit circle, right, we know coterminal angles end in the same place. So here's the only place sine is 1. So pi over 2, sure, but then also all of my coterminal angles with pi over 2, whether I go positively or I go negatively. And we remember from last week that to find coterminal angles, I add or subtract 2 pi. So again, what this k is saying is just any multiple of 2 pi. My local minimum is going to be -1, and it's going to be at negative pi over 2, and any coterminal angles with negative pi over 2. You could also call it 3 pi over 2. Because that's a coterminal angle with negative pi over 2, right? 3 pi over 2 or negative pi over 2 end in the same place. Intervals of increase are what x is equal to when the function's getting bigger. So I can call it negative pi over 2 to pi over 2 because that is where my line's going up, right? From x is negative pi over 2 to x is pi over 2. And then also then any coterminal angles with any interval, any angle in that interval. And then decrease, I'm going to go pi over 2 to 3 pi over 2 because that's where my x is when my line is going down. And again, or any iteration of that. Finally, my end behavior, this is usually when we talk about x go to infinity, positive or negative, but as x goes infinity, positive or negative, I'm just having the same wave over and over, right? So we say it oscillates between -1 to 1. Oscillates means goes back and forth. So if I was just going to move my pen like this forever, my pen is oscillating. So those are like our key features of sine. Most important parts up here and right here. That sine is odd. Okay. Cosine. If we return to our cosine graph, we know at 0, I also have to make an edit really fast. I'm going to make that pi over 2. I'm going to make this pi, just so it's the same values as here. We know at 0, cosine is at 1. So here is going to be 0. At pi over 2 is 0. And at pi is -1. This way we have all of our points. So I'm going to graph 0, I'm at 1. Pi over 2, I'm at 0. Pi, I'm at -1. So negative pi over 2, I'm here. And then I can extend it because I know that it is symmetrical. And we usually want it to be curvier. But again, this is the frame of reference we're looking at before. This is a better way of what it looks like. But there's a frame of reference, but it's going to keep going, right? So here I'm crossing the x-axis at all of my pi over 2's, right? So I'm going to call it pi over 2 plus or minus pi k. So here to here I've added pi. Here to here I've added pi. Right? I went from negative pi over 2 to positive pi over 2. And then my y-intercept is going to be at y equals 1 because I crossed the y-axis at 1. My domain and range are going to be the same as sine, right? I can plug in any numbers, and I can only get out between -1 and 1. I'm also continuous, no holes, but cosine is even because if I was going to fold on the y-axis, my points would line up with each other. They would overlap each other, and that's our definition for even. My local maximum is going to be at 1, or at 0, sorry, or it's going to be at 1. So y is 1 when my x is 0 or 2 pi. So 0 plus or minus 2 pi k. 0 and all the coterminal angles was 0. And my local minimum is going to be when y is -1. And that's going to be when x equals pi plus or minus 2 pi k, right? Because I went from pi to negative pi. And on my unit circle, what that actually looks like, right? Here's where cosine is -1. That's when I have pi. So I can go positive pi or I can go negative pi. And so then all the coterminal angles with that will give us cosine -1. So where am I increasing? I'm going to call it pi to 2 pi, because my line's going up from pi to 2 pi. And then plus or minus 2 pi k, coterminal with all the angles in that interval. And where am I decreasing? I'm going to call it 0 to pi, because that's what my x is equal to when my y is going down, my graph is going down. Finally, my end behavior is going to be the same. I'm going to oscillate between -1 to 1. Cool. Hope that kind of makes sense. Our cosine graph, our sine graph, and all the key features of it. Just like with sine, I really want to make sure we know domain and range, and that cosine is even. Sine odd, cosine even. That also feels right to me. So hope this helps. Hopefully it gives you a place to start from so that when you come back, it makes more sense.